This is the second video for chapter 2.7 and 5 and 6, 2.5 and 2.6. Okay, so we're going to move on now. Find the domains. Oh dear, put my hand on it. Find the domains of rational functions. When you are, we've already done this a couple of times, so we're going to look at it. We're looking at square root. X can only, x has to be greater than or equal to 0. As well as the square root itself. So what this means is that what is inside the square root must be greater than or equal to 0. But we also don't want it equaling something that is less than 0, right? So this is saying that a has to be less than or equal to 0. X has to be greater than or equal to 0. I'm sorry, I said that backwards. Greater than or equal to 0. I think I was brain dead. Hang on. Now this should be a has to be greater than or equal to 0 also. Otherwise we would consider it an extraneous solution because it's not a function. Okay, we also have the denominator. These are not minus signs, I'm sorry. Think of these as, these are like both. I'm just put triangles here. I don't think those are minus. Okay. X not equals 0. That gives you an asymptote at a denominator. 0. Okay, find vertical and horizontal asymptotes of a graph. Vertical or x equal asymptotes. What is the rational function, which means we have a denominator that isn't 1. Set the denominator equal to 0 and solve that. That gives you your x equal. So for example, if I have 1 over x minus 2, x minus 2 equals 0, x equals 2, that is my x equal asymptote. When it comes to y equal asymptotes, there's a little trick I've learned, and that is to force the numerator and denominator be of equal degree. Then circle the leading coefficient, okay? So you have the option of where if it equals a number. So if you do that, so we have y equals 3x squared plus who cares what over 2x squared plus who cares what. All we're going to do, I'm going to change color so you can see, is circle that. So my y equal asymptote in this situation would be y equals 3/2. That's my y equal asymptote. My y equal asymptote is your horizontal asymptote. Now, if on the other hand you have y equals, this is where we're going to get 0 over a number. What if I have y equals x plus 2 over x squared minus 3? Well, notice my top doesn't have an x squared. So now what I'm going to have to do is I force it to have an x squared by giving it a 0x squared, right? I can add 0x squared because I'm not really adding anything. Now, if I circle those, I get y equals, sorry, stop. I have a little button on my thing. I get y equals 0 over 1, which is 0. So the asymptote is y equals 0. All right. Now, the other situation is when the denominator has the forced one. So I'm going to put that over on this other side of it. Oh, I am so sorry. I don't know why that happened. So now what if I have 2x squared plus over x minus, like that? Well, now I'm going to put the 0x squared on the bottom. Now when I circle those, I have 2 over 0, which is undefined. That's this situation. And so when it's undefined, 2 over 0, then I don't have an asymptote there. I don't have a y equal asymptote in that situation. So we're going to move on. All right, sketch the graphs of rational functions. Simplify the given equation. Find and plot your x and y intercepts. What is x when y is 0? What is y when x is 0? Find and plot vertical and horizontal asymptotes. I just told you how. Plot a few critical points between all and around all your asymptotes, and then sketch in your graph. All right, this is a detailed guideline on graphing rational equations. Okay. This is what we were talking about. Okay. I've just been talking about the whole time. Slant asymptotes. Now, a slant asymptote, if I do the division that this rational equation implies, then the solution minus the remainder, so no remainder, right? We're going to cut off this remainder bit. The solution is the equation for my slant asymptote. We'll have to do the division either through synthetic division if it's a linear denominator, or long division if it has a degree of 2. Okay, so go do your in-class practice. Here's your answers. If you have any questions, come in and see me.